I'm Judy and I'm going into my 4th year of mechanical engineering and biomedical science at Monash University. I've been fascinated by STEM since I was in high school. I decided that I would want to go into the medical field because being able to provide help to those who might be in more difficult circumstances was something that I wanted to be involved in the future. And I've always been interested in the mechanism behind the devices that we use on a day-to-day basis, and so that's why I chose to pair engineering with biomedical science. Over the summer, I've been undertaking my summer research project with my supervisor, Associate Professor Sean Gregory at Create Lab, which is now located in the new Victorian Heart Hospital. I wanted to do the summer research program because I wanted to get a glimpse of what it was like to work in a research environment, more particularly research in the bioengineering field. I wanted to learn new research skills and develop technical skills and collaborate with other students, academics, clinicians and other professionals who are currently studying or working in research. On top of that, I wanted to be able to make a meaningful impact. My summer research project has been about developing a reproducible manufacturing process for a component of the sutureless inflow cannula, which is an alternative way to implant ventricular assist devices or VADs. VADs are medical devices that provide temporary heart support to patients. So the slick aims to reduce the risk of complications and also improve the efficiency of these procedures by being a singular insert and pull-up mechanism. With this, we hope that the procedure for VAD implantations will be improved so that more patients can receive the heart support that they need while waiting for a heart transplant. My project was focused on selecting a suitable biocompatible material for the main body of the slick and then developing a manufacturing technique that we could use. With the CAD models of the mold that I designed, we ended up 3D printing them out of resin and then testing them with silicon as a proof of concept, and it worked quite well. So now we are focusing on improving the design of the mold to make it more easily removable and also to increase ease of disassembly. It's been a very collaborative environment and there is an abundance of knowledge in the lab. Something that I wasn't anticipating was the range of skills that I've developed. I didn't expect to learn how to use a tensile tester, how to do simulations on ANSYS, how to do silicon molding. In the future, I would really still like to be involved in the biotechnology and medical engineering field. I'd really like to utilize all the knowledge and practical skills that I've developed and acquired in my time at university to try and develop more accessible technologies to help people in the future. And then on top of that, I'd really like to be knowledgeable enough to make this knowledge more accessible to everyone as well.